Okay, so the first problem for today's warm-up reads, what is a molarity of a 50 milliliter sodium carbonate solution made by dissolving 12.92 grams of sodium carbonate decahydrate in 50 milliliters of water? So for this one, you just got to remember that a hydrate is a compound that has water embedded into it, and we have a special way of writing that. So in this case, for sodium carbonate decahydrate, we have Na2CO3 with 10 waters. So one thing to make sure that we can get out of this is that this is a 1:1 ratio of sodium carbonate to water. When we take the when we're finding the molar mass, we need to find the molar mass of this entire thing. So first thing, as I always say, convert to moles. That's the first thing we got to do. So we got 12.92 grams Na2. Okay. Now again, when we got to consider this, we got to consider the mass of the entire compound. So this ends up being 286.09 grams for every 1 mole of this hydrate compound. Now, what's going to happen when we dissolve this compound in water? Well, these waters here are going to end up dissolving and becoming part of the solution, leaving us just with the sodium carbonate. So I know that for every 1 mole I'm going to end up with 1 mole of just my salt compound. And when I work this out, without rounding yet, I should end up with 0.045160614 moles of sodium carbonate. Now that I have moles, this just becomes molarity problem. So I have a volume of 50 milliliters. So I know that molarity is equal to my moles divided by my amount of liters. So my final molarity, once we account for sig figs, 0.903 molar. And that is our answer. All right, for number 2, it says, what would the new molarity be if you take a 23.5 milliliters of a 3.2 molar solution of potassium nitrate solution and added 345 milliliters of water? So in this case, we gotta understand what we're doing. We have one solution. We have a specific amount. In this case, we have 23.5 milliliters of a 3.2 molar solution. And I want to make a new solution by adding 345 milliliters of water. So again, we are adding 345 milliliters to the 23.5 milliliters that I already have. So in this case, first thing we got to do is establish what we have. So I know I have a specific molarity given to me of 3.2 molar with an initial volume of 23.5 milliliters. I know that I have another volume. I'm going to make that new solution again by taking this 345 milliliters and adding it to my 23.5 milliliters. So when I do that, I'm going to get a new volume of 368.5 milliliters. And I don't know what my new molarity is going to be. That's what I'm trying to solve for. So this is actually a straightforward just dilution problem where I know that M1 V1 is equal to M2 V2. I don't have to worry about conversions as long as I'm consistent. In this case, I have milliliters on both sides. So if I keep this as is, then I should have molarity and milliliters on both sides. So I'm just going to set this up as 3.2 times 23.5 is equal to M2 times 368.5. This ends up being 75.2. And we get an M2 value of 0.20 molar once we account for sig figs. So that's the answer to number 2. Please let me know if you have any questions. You can always message me on Canvas, and I'll try to get back to you as soon as I can. All right. Hope you guys have a great day. Make good choices.